Hello, everyone. So we have another AMC 12B problem. So this was number 24, so which meant to be challenging. So we have a triangle. M is the midpoint of AC, CN is the angle bisector, and X is intersection of the median and bisector. So it's already complicated when you just write those part, right? So let's go ahead and draw a figure so we can kind of see how things are look like. So I'm gonna go with just of a triangle. So let's assume this is my triangle. Okay, this is A, B, C. And if I need to change my figure, I will. But for now, at least I will see how things are going to be related. So the M is the midpoint of AC. So which is something right there. So these guys will be equal. And then CN is the angle bisector of ACB. So the ACB, so the CN would be something like this. And then what we know is this angle right here is the same as this angle. So as soon as I see angle bisector, so two things that I do need to keep it in mind. First, angle bisector theorem, if I do have some sort of ratios. Two, angle chasing, because whenever you have two angles are equal, so maybe I can just label some of the angles to get some nice like relation or results or some connection with other given sides and stuff. So those are the two main things I would say good to keep in mind. And we are told, okay, so the median and angle bisector are intersecting at one point. So let's draw the median as well then. So the median is just the segment you take from the point B to the midpoint of AC, and their intersection is given as X. Okay. And then this was CN. And AC is 2, which is why this is going to be 1. This is going to be 1. And BXN is equilateral triangle. So BXN. So in my figure, it doesn't look like equilateral triangle, right? But I don't care. So we just need to use the feature. So if you don't like how this equilateral triangle looks like in my figure or in your figure, so you can now change your figure slightly. You can just drag this a bit maybe this way, and then this one to this way, and whatever you want to do, you can just do it as to make this guy as equilateral triangle, but we don't really need that. So this is what we have, and then we want to know bx squared. So this is the distance we want to find it. Okay, so we have to relate the angle bisector, the median, and the equilateral triangle somehow each other. So the similarity is usually are one of the best tools in geometry. So maybe we can try hunting for similarities, but we don't really have much given. So maybe we start with labeling the angles. I'm gonna call this is alpha, and this is alpha. And this is 60, so this is alpha, so the angle A, so right here, should be 60 minus alpha, which is because the exterior angle theorem, basically, or you can just say this is 120. 120 plus alpha plus something should be 180, so that always going to be 60 minus alpha, so you could have done that as well. Okay, and we have 60 and alpha, and another 60 in B and C. So that's 120 plus alpha. So which is why we can say this angle to be another 60 minus alpha. Okay, I hope that's clear. So look at the triangle B and C. Alpha 60 and 60 plus this part has to be 180. So we have 60, 60, 120. So to get another 60, to get 180, we have another 60. We need another 60, but we have to eliminate this guy, so subtracting alpha. That is something we could do that, or we can add this angle by this, which is going to give us 120 minus alpha, which has to be this angle, or you can say this is going to be 60 plus alpha, because we got 60, 60 minus alpha, which is 120 minus alpha. You could get this part first. So, and then write this after, but I'm going to add these to interior to get this exterior. So this angle will be 120 minus alpha. So if this is too complicated already, the reason I'm trying to kind of find the angles to see if there is maybe some similar triangles, okay? But I do see that. And then also I like to keep that in mind that I need to use AC because that's the only number that we know. And maybe we have to relate that triangle to AC somehow, which is only way, I mean, easiest way probably is kind of find some similarities. So which is why I'm trying to kind of chase the angles to see if there is a pairs, okay? So I would say the triangle ANC, so let's go ahead and write that. Triangle ANC has 120, 60 minus alpha and alpha, right? But we do have something going on as well. So 60 right here. So this means this is 120. This angle is 120. This is 60 minus alpha. This is alpha. It looks like the same angle as this triangle. So which is why we can say this triangle. So the A was 60 minus alpha. So in this triangle, like I just showed right here, the B has the same alpha. The N was 120, which is going to be X in our second triangle, and C. So these two triangles are similar by angle, basically, right? And we are going to write the ratios, but we don't really have much stuff. So which is why I'll just try finding another pair if we can. So we did that part. So how about the largest triangle? So we have 60 minus alpha, 120 minus alpha, and 2 alpha. So that is the triangle that we have. So maybe because I like to use the 2, so let's go ahead and write this as well. ABC is similar to, so in ABC we have 60 minus alpha, 120 minus alpha, and 2 alpha. But do I have any other triangles that has the same angle? So I think we do have this triangle. So because this is 120 minus alpha, and this is 60 minus alpha, and then C is 2 alpha. So I hope that makes sense. So the A in this largest triangle is 60 minus alpha. So in this B and BMC, 60 minus alpha is B, so that is my corresponding side, so that's B. And then ABC, so B was 120 minus alpha, so this M is 120 minus alpha. So that is gonna be the order. This reasoning is the same, angle. Okay, so we have two similar figures at least. We can hunt for more, but let's try to see if we can get something out of these two. So the A and C in this triangle, 120 degrees is opposite to 2. So I'm going to start with that because that's the only known number. And divided by NC because I like to relate this side instead of this side because there is something going on with 60 on this side. So maybe I should label this as A. Actually, let me use different color for that piece. So if I call this is A, so BX will be A, and then this is A, and then NC, maybe I can call this is B, okay? And we do have now something A and C, about the side that is opposite to 120 was 2 in A and C, and then BXN, so BXN, BXN, let me double check, BXN. I think that wasn't correct. ANC, 60 minus alpha 120, 60 minus alpha 120, and alpha, I think it was BXC. So BXC, so this should be BXC. So I'm not sure why I changed this number, but maybe I should be careful, but at least we were able to figure this out for now. So that's 2 is opposite 120. 120 is opposite to BC. So let's write that. This is my ratio of the side that is across the 120 degrees. And now maybe I should use 60 minus alpha in A and C because that is this side, so and C, so that will be A plus B over 60 minus alpha is opposite to B in the BXC, so that is something we know. We can write the next one as well. So the third side is like AN, which may not be useful right now. and which is opposite to alpha, and then the bxn alpha is opposite to A. Okay, so we have too many unknowns, so we cannot really do anything at this point. Let's try the second one as well. ABC, this triangle, the 2 was known, which is AC. AC is opposite to 120 minus alpha. In BMX, right, this triangle, BMX, this triangle, 120 minus alpha is this angle, which is opposite to BC. So 2 over BC equals, in the original triangle, ABC, maybe I can take BC now, because that's something we are using in the other triangle as well. BC is opposite to 60 minus alpha in ABC, but BMC, 60 minus alpha is opposite to 1. So which is actually nicer because we are going to be able to get BC. And the third side for the ABC is AB, which we don't probably need to write it, but let's go ahead and write anyway. And AB is opposite to alpha. And in this triangle, BMC, the 2 alpha is up to BM. So I'm going to write anyway. So from the, this part, if you do cross multiplication, so you get BC. So which is root 2. As soon as we have BC, I can use this as well. So if I just take these two and replace BC and root 2, so you will get 2 over root 2 equals A plus B over B, right? And that is just the A over, like you can just write A over B plus 1, or you can just do cross multiplication now. So let's do the cross multiplication. So the 2B equals A times root 2 plus B times root 2. And if I want to get like A or B alone, because, there's a triangle right here, and then I do know this is like root 2. And if I know the A and B in terms of each other, like if I change this to be in terms of B or B in terms of A, then in this triangle, I can use law of cosine. The reason I can use, because this side is known. The angle 120 is the nice angle that we know the cosine value for. And if you know the other two sides in terms of one variable, then it is good to go with the law of cosine. So for that reason, I'll find B itself in terms of A. So let's try that. So that should give us 2B minus B root 2 equals A root 2. And pull the B as a factor, so that should be 2 minus root 2 equals A times root 2, and divide by that expression, so you will get A times root 2 over 2 minus root 2. You may leave it that way, but maybe it's better to simplify a bit, so that should give us, multiply this by its conjugate, so 2 plus root 2 and 2 plus root 2. So the B would be, if you multiply the denominator, you get like difference of squares. So 4 minus 2, which is 2. So if you multiply A root 2 by this, you will get 2 times A times root 2. And this times root 2 will be root 2 will be just 2. So you will get 2A. And the denominator was just 2. So we can actually get a bit better expression. So divide by 2's. So you will get A times root 2 plus 1 times A. So I can take the A. So that will give us root 2 plus 1. Okay, at least this is much better than the fraction. So as a last step, let's try using now the law of cosine. And if you don't remember the law of sine, it was like this. So you take the one side of the square, and then that is equal to the square of sum of the other two sides minus 2 times the second and the third side that we have on this side of the equation, not the one that is alone, times cosine of the angle measure that is opposite to this side that is alone. So in that case, I can take the root 2 as A, so that should be root 2 squared equals A squared plus B squared. B is this number, so if you square that, so you will get A squared times the square of this expression as well. So I can just write as 2 plus 2 root 2 plus 1. If you don't get this part, I basically take this root 2 plus 1 and multiply by itself by using square of binomial. So I just did that. Minus 2 times BC. B is like, B and C is just basically these two sides. So A times root 2 plus 1. And then times cosine 120. So cosine 120 is one of the angles that we have to remember. So that is what we are going to plug, right? So if you don't remember cosine 120, just a reminder. So we can just use our unit circle or even right triangles if you really want. So on the unit circle, right? Since we cannot use a calculator with this, so I should use this. So I'll take this as like 120 degrees, and that will give us this to be 60 degrees. And what we want is the cosine of this terminal point, so which is the x coordinates of this, so that will give us this distance. And if you take this as 1, and this is 30 degrees, this is 60, so there is 30, 60, 90, so this side should be half of the hypotenuse, which is going to be 1/2. But the cosine value on the second quadrant is negative, so that is why we just need to change this to negative 1/2. So that is going to be what we are going to plug it into. Okay, so let me try to simplify a bit. So that is 2 equals, we have a squared, and then if you look at this one, it's also a squared. So I'm going to pull all these a squared, and that should be 1. And then 2 plus 1 is 3, and then plus 2 root 2. And since this is negative 1/2, this is negative 2. So those like negative 1/2, this is negative 2. So that's just 1. So only thing will be left is going to be root 2 plus 1. And now we do have 3, 4, and this is like 5, I guess. Let me double check. 3, 4, 5 plus 3 root 2, right? 5 plus 3 root 2 times a squared is just 2. And what we want is just to divide that 2 by this expression to get a square. So if I do that, so that will give us 2 over and 5 plus 3 root 2. And you can do this, use same idea that we did right here by like the conjugate of this expression. So 5 minus 3 root 2. And if you multiply this by 5 minus 3 root 2 as well, so you get 10 minus 6 root 2. And that looks like the choice A. And the denominator will be 25 minus 3 root 2 squared, which is 18. That will give us 7. So that is indeed choice A. So I hope the solution is not too complicated. So if you are lost at some point, so just pause a minute and look at the previous steps and see if you convince yourself. And the rest just using some of the like topics, some of the backgrounds in trig and geometry. Otherwise, the question wasn't too bad. So we did use like the similarity to get some other information, and then we used law of cosine, and that was another thing that we had to remember since this is AMC 12. Okay, so I'll see you in the next video.